Okay, so video number 3. The past two videos have concentrated very much on the sort of user interface, drawing a grid, drawing shapes where we want them to. This one's going to concentrate on the representation of the board before we draw it. So as a list of lists, and I'll take you through that. There's no more imports here, and I don't think I've changed anything to those. The rest of these change quite a lot. The biggest change is the fact that I've introduced this grid variable, this pieces per column list. This is a list of lists. This is just a flat list, and last column clicked and player, so I know who's playing. So let me show you this picture, and this will explain how the grid is represented. So let's say this is the current game state. This grid here, which is a list of lists, it's 6 lists of 7 integers, and you can see how it corresponds to this situation. 0 means nothing's there, so nothing, for instance, is in the first column. 1 is player 1's piece, 2 is player 2's piece, and you can see that they're sort of piled up on each other just like they are here. This list here just holds the number of pieces that are in each column, so it holds nothing about whose pieces are which, but you can see the first column has no pieces, the second has 1, 2, 4, 3, 0, 0. So let's say that it's player 1's turn and they want to move here. They will just click anywhere in this column. It doesn't matter if they click down here or up here, and we can now specify exactly the grid reference for this piece, which should be 4, 3, by looking at the column that they clicked, which gives us 4, and the number of pieces that are currently in there. This happens very often when you've got 0-based lists like this. You will use a count, which not only tells you how many pieces are in, but it gives you, in fact, the reference of the next one. So this is quite useful. This then is going to be used for 2 reasons. One, it's going to find the row into which a new piece in that column should be added. And secondly, when these get up to 6, I'm going to be able to determine that no pieces should be added because this column is full. So now to actually get the 4, 3, pieces per column col, where column is the column that was clicked on. So this is the 0th, 1st, 2nd, 3rd, 4th element. We've clicked on col, so pieces per column col gives us the row. So the row is pieces per column col, and then the column is just the col that's worked out using my column function, and then we can go ahead and draw our piece here. We haven't got a method yet, a function yet to draw this grid. We'll do that in the next video. After we've done that, all we need to do is update pieces per column by 1, because this 3 needs to turn to a 4 after we've put a new piece in there. So this line of code just says this is a list of 1, 0, and I multiply it by cols, which gives me one of these there. And then I do that 6 times, 1 for each row, and I end up with 6 rows of 7. That does make it slightly weird, because to reference this, you actually reference it yx rather than xy, because you pick which column you want first and then how far into that column you go. But the reason I did that is just so that when you do represent it here as a literal, that should be a square bracket, when you represent it here as a literal, it does actually look like the connect4 board. Yeah, whatever, you could do it the other way, but it would be unintuitive for a different reason. So we've done our draw line, draw polygon, draw piece. This is our draw grid. All of that works, but our update has now got quite a lot of code in. let's have a quick look at mouse press first. I've got this idea of last column clicked. All that my mouse press is going to do is set the value of last column clicked, and then update will take that value and change the grid underneath, and then later on will draw all the pieces on the basis of the updated grid. So let's have a quick look at this. We now I only want to react to a click if it's a left click and the last column clicked is -1. The reason I've done last column clicked is -1 is in the snake game that we did, it was actually possible to execute 2 key presses before the update had run, and so I prevented this. To be honest, I don't think it's necessary. It's very difficult to click twice so quickly that you're going to get two clicks in. But what essentially happens here is that the mouse press checks that the last column clicked is -1. Then if it is, it sets it to the column of this click that happened at XY, and update, having processed that column click, sets the last column click back to -1. So it's a way of my mouse press being able to determine that update has run since the last mouse click event happened. If I clicked twice very quickly in succession, I would have set last col clicked to something other than -1, and then I'd come into this again and check that in fact last col clicked is not -1 because I've clicked again before the updates happened, and that will allow me to ignore the second mouse click. Okay, so I just set the last column clicked to the column as long as last column clicked is -1. And there's actually a bit of redundancy there. I seem to have checked whether last column clicked is -1 twice, but that's not too much of a problem. This idiom is quite nice in Python. If you've got a value that's either going to be one thing or another, you don't actually have to write a big full if statement. You can just do it in one line like that. Okay, let's look at update. Last thing that we need to look at. I need to change who the player is and what this value of last col clicked is, so I've got to use this global keyword. I then check as long as the last column clicked is not -1. So what's going to happen is update's going to run again and again and again and again really fast, and I don't want to do any of these things if the user hasn't clicked. This is going to be a very common situation, that last col clicked is not equal to -1. That means I'm sitting there thinking about my move, and update is happening again and again and again, but it doesn't want to do anything as long if the user hasn't actually clicked anything yet. So when I click something, last col click will cease to be -1, and then the next time update is called some fraction of a second later, all of this will execute because last col clicked is now not -1. The first test I do is to see if pieces per column in that column is less than rows. If this is not true, then the column is full, and I don't want to do anything. I just want to totally ignore the click in that case. So you can go ahead and click anything you like. It doesn't give you an error message. It just doesn't do anything for you. You've got to click on a valid column before it does it, assuming that you have clicked on a column where you've got room to play. Then it prints a little message there. That's just a sort of debug message. Player 1 has placed a piece in column 3, for instance. And then this is the updating of the grid that I showed you on that slide. I won't go into that. You can go back if you want to check it. Increment the pieces per column, because now I've added another piece in that column, and then player equals 2 if player equals 1, else 1. Okay, so this thing here is going to evaluate either to 2 or to 1, and that will toggle player. So player just goes backwards and forwards. When I set the value in the grid, I actually set it equal to what player is at the time. So if player's 1, a 1's going to go into the grid. If player's 2, a 2 is going to go into the grid, and that's just going to go backwards and forwards each time update is called on a valid basis that a column has been clicked. And then just for the purposes of this video, I print the grid and I print the pieces per column. And I think that's it. So we can just see that running. Here's our empty grid. Don't forget nothing's going to appear here because we haven't done any drawing. But let's make a bit more room here. If I click in the middle there, then notionally a piece has come in here and fallen down to this point. And we can look at the grid here. These are different rows of the grid. First row, second row, going up, third, fourth, fifth. This is the top row. And we can see a 1 for player 1 has appeared in the middle of the bottom row, which is as it should be. And this is the pieces per column, which is now 1 because we put 1 in that column. And let's click that column again. Anywhere in that column will do. And we can now see there are 2 pieces in that column. On the bottom row it's 1, and on the next row up it's a 2. If we keep clicking there, I've now got, you can see 1, 2, 1, 2, 1, and there's still a space there, so let's click there once more. It's now full. We've got 6 pieces per column, and if I click in that column now, it doesn't do anything. It's just going to ignore that click. Okay, so I think you've got a reasonable idea of how the board is represented. In the next one, we'll actually draw the contents of those of that grid list.